The program will begin shortly. This is a microphone. Microphone 1, 2, 3. There should be audio coming through. Yep. All right.
Testing, 1, 2, 3, testing, audio test, testing the mic. All right, testing, keep testing, 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 1, 2, 3. Okay. Okay, testing, testing, 1, 2, 3, testing, audio test, testing, 1, 2, 3, testing, testing, test, audio test, test, 1, 2, 3, testing, testing.
Hello, everyone. My name is Dave Brain, and I'm really proud to be the chair of the Department of Astrophysical and Planetary Sciences. So before I say a few words, I just want to look into that spotlight in the back and make sure it's okay to start. We have everyone in that's coming in. Great. Thank you. Okay, off we go. Graduates, friends, family, faculty, and staff, welcome to all of you, and thank you for joining this very important occasion. We are here at this certain place, at this certain time, to celebrate you and your certain achievements. But it would be disingenuous of me not to acknowledge that it is a time of great uncertainty for many of you, for many of us. Uncertainty is not typically a pleasant feeling, but it is one that scientists live with every day, as you know. Uncertainty is a defining characteristic of a good scientist, embarking on an exploration into topics and ideas for which there are not yet answers. A good scientist is never certain. Nevertheless, maybe it would be a little more helpful right now to tell you about a few things that I am certain of. First, I am certain of the value to you of having studied astronomy, the skills that it has provided, the critical thinking muscles that it has flexed, the ability to think about large, difficult, abstract problems that will serve you well regardless of what trajectory you take in life. I'm also certain of the importance and benefit of continuing to expand the frontiers of astronomical knowledge, the value of understanding the universe from the largest to the smallest scales, something that no other department on this campus can claim, of the technological advances that result from progress made in our field, and the ways in which astronomy research, from astrophysics to planetary science to solar physics to space physics, makes life better for all people on this planet. I'm certain of the less tangible importance of astronomy to society, beyond the technical advances, the insights about where we've been and where we're going, whether we're alone in the universe, the sense of perspective that it brings, and how this perspective reinforces the importance of being kind, for me, the central lesson of astronomy. These are great things for you, for our field, and for society, and it comes at low cost. Out of every $100 the average American pays in taxes, about 50 cents goes to NASA, down from a peak of $4.40 during the Apollo era in 1966. Of those 50 cents, about 15 to 20 cents goes to science. About 10 cents out of every $100 in taxes goes to the National Science Foundation. Something like 60 cents goes to the National Institute of Health. Altogether, on the order of $1 of every $100 in taxes goes towards science. Low cost, big benefit. The good news is that Americans have favorable impressions of scientists. The bad news is that the percentage of Americans who say they have a great deal or fair amount of confidence in scientists has decreased by 10% since before the pandemic. Those numbers are still high, but they're going down. 89% of Americans think scientists are intelligent. 45% think they're good communicators. 47% think scientists feel superior to others. What can we do? For me, these statistics underscore the importance of a 5-word phrase that I share at least once in every class that I teach. So many of you have heard this before. Science without communication is pointless. You could be the most capable scientist in the world, but if you cannot or do not communicate what you learn, it was a purely selfish endeavor. What was the point? Science without communication is pointless. Living this phrase Being an ambassador for astronomy and for science in general is now your charge. No matter what you do in life, no matter where you are headed next, in the next hour, you will graduate from this department trained as a scientist. You are an example to others for the rest of your life of what a scientist is. Maybe that's in your job, maybe it's to your relatives, but it's also when you least expect it, and random moments and encounters with others you will never see again, on airplanes, in grocery store lines, at the playground with your kids talking to another parent. I know that you will carry yourself well in those moments. You will leave people with the impression that a scientist is a person, a human being like anyone else. That a scientist is not other. That a scientist is curious about important questions. That a scientist doesn't feel superior to others. That a scientist feels and has opinions, but is able to dig through their feelings, not push them aside, dig through their feelings in an unbiased search for understanding. That a scientist has the humility to admit when they were wrong and change their mind based on evidence, and that this is a virtue and not a weakness. This is a weighty request, a lot of responsibility, made a little lighter perhaps by the fact that you get to represent such a wonderful, beautiful, and awe-inspiring field, the best field at this university. Before I close, I want you to take 10 seconds and think about something wonderful, beautiful, or awe-inspiring that you have learned about in this department. People in the audience, faculty, anyone else with a science degree, you're encouraged to spend the next 10 seconds doing the same thing for your own field. Wonderful, beautiful, or awe-inspiring. Just think for 10 seconds. Ready? Go. Did you think of something? Okay, well now I'm going to ask you for something. On the count of 3, I want you to say the thing that you were thinking about that is wonderful, beautiful, or awe-inspiring out loud, not quietly, loudly. I want you to fill the dome. I want it to be an affirmation or a testament. You ready? 1, 2, 3. Okay. So glad that worked. Okay. Okay. So I may be a scientist, but I'm now certain that you're up to this task. So I speak for the faculty and the staff when I say that we are so very proud to have gotten to know you and watch you grow during your time in APS. We hope that you keep in touch and continue to feel that you're part of our community once you have left this campus. Thank you for your attention, and let's start the party. So next we'll have an astronomy presentation. So I'd like to call forward one of our graduates, Sylvan Arnold, who'll be presenting. And then I also want to recognize, and we'll come back to this also at the end, Marie Antoinette Banks, who will be navigating as well. Marie is a graduate of a different department, but an employee here at Fisk. Theater and dance, I think, is that right? Yeah, great.
Thank you, Dave. And thank you to Marie Antoinette, because she is going to be controlling all of the visuals we see on the dome during this section, and so she's really the one taking us on this tour of the universe. And thank you to all of our graduates for all of our hard work these past 4 years, and to our faculty, and everybody who is here to support us today and has been here to support us through these past years. Before we get into our astronomy presentation and we kind of delve into our darkness, I'd like to point out that this exit sign here is not above these exit doors, so if you need to leave during this section, please take a step to the right of the exit sign, lest you find yourself walking into a wall. Additionally, we'd like to ask for no flash photography during this section, just because it's going to be very dark. And as we begin this section, as we recollect the past few years, I think that there is no better place to start than our sky. And this is the sky as we see it from Boulder, from this very campus, in fact. But since this is the astronomy graduation, wouldn't it be all the more fitting to see our nighttime sky? And so Marie Antoinette is going to take us several hours into the future and show us our sky at around 10 p.m. tonight, so that we can see those stars that have doubtless inspired so many of us and are probably the reason that many of us are sitting in this room here today. Throughout the history of humanity, various cultures have looked to the stars, and they have told stories, and they have used them for timekeeping, for navigation, and for lots of other purposes. And they have connected them to create constellations that we still use in order to see different parts of the sky, determine where in the sky we're looking. And once you've sorted those stars into constellations, if you look night after night, you can begin to notice that there are a few bright stars that don't quite fit that mold. They don't stay in their constellations, they wander. And ancient people noticed these wandering stars. We have a couple of them on this side of the dome tonight. And they gave them names. The ancient Romans called these ones Mars and Jupiter. And we know them today as our planets. And piece by piece, over the last several thousand years, we have put together a view of our solar system that looks more familiar to how we really think of it today. And through these sorts of advances, we are no longer constrained to just the surface of the Earth. So let's take a trip to our solar system for ourselves to really see what we have discovered and what's left to discover. So as Marie Antoinette takes us off the Earth, we'll begin to see a view of the Earth that few people have ever truly seen. And we came from right around there in Boulder, where we've spent the past 4 years perhaps spending nights in SBO, in Duane completing problem sets, even just going through the day-to-day struggle of trying to figure out which door in Duane is unlocked and will let you in. But let's leave all of that behind for a second and see what this was really all for. Take a minute to remember why we love astronomy and why we will continue to love astronomy. So as we head away from the Earth, the first thing that comes into view is our moon, our closest neighbor and the farthest away from the Earth that any human has ever been. And if we've learned anything, it is perhaps that space is big. So it will take a second before we can start to see the rest of our solar system and all of our planets before us. But with our sun at the center, we have our nice, neatly organized solar system with our 4 inner rocky planets, Mercury, Venus, Earth, and Mars, followed by our 4 outer giant planets, Jupiter, Saturn, Uranus, and Neptune. And we have sent spacecraft for, at the very least, a flyby, if not a more intensive study, to every single planet in the solar system. But we would be remiss to ignore what is perhaps the star of the show, our sun. And for this reason, in 2018, the Parker Solar Probe was launched to head closer to the sun than any spacecraft ever has before, to literally fly through the sun's corona to touch the sun. And just this past December, the Parker Solar Probe made its closest approach to the sun, flying through the corona. And this is a remarkable feat, both because of the proximity to the sun, of the incredible temperatures that the Parker Solar Probe has to withstand, and also because when it was making its closest approach, it set a new record for the fastest moving spacecraft ever created by humans. And the Parker Solar Probe will go on to give us valuable information about our sun and perhaps about other stars that are just out of reach, that are too far for us to touch. But our solar system is a diverse place, and there is something to be said, not just for these incredibly hot regions near the sun, but also for the colder, icier regions in our solar system. And for this reason, just this past October, the NASA spacecraft Europa Clipper was launched. This is following the launch of the ESA spacecraft JUICE, the Jupiter Icy Moons Explorer, by 18 months. And together, these spacecraft will head out to the Galilean moons of Jupiter to explore these icy moons, to tell us something about the geology of these moons, about their formation, and perhaps about the potential for life outside of the Earth. And the Galilean moons, such as Europa, are so called because they were viewed by Galileo through his telescope hundreds of years ago. Moons in our solar system are perhaps not a new concept. We've known about our own moon for millennia. We've known about other moons for hundreds of years. But even so, even something that seems so simple as planetary moons still offers lots of surprises. When we began this semester, the planet in the solar system with the largest number of moons was the planet Saturn, with an incredible 146 known moons. But even as recently as March, through meticulous observation, even more moons of Saturn have been announced, bringing the new total number of moons for the planet in the solar system with the most moons to 274. There is always something else to look for, something else to discover. We'll never run out of surprises, even inside our own solar system. And it's worth noting that in 2021, the James Webb Space Telescope was launched. And this was going to give us incredible information about galaxies that formed early in the universe, and it has. It has certainly given us invaluable information about how galaxies form. But even though it's meant to look as far away as it can into the outer reaches of the universe, it still turns out to be a useful instrument to use within our own solar system. You see, recently, the James Webb Space Telescope was used to look at Neptune. This is how the Hubble Space Telescope would see Neptune from Earth. These are color-enhanced images. But the James Webb Space Telescope looks at different wavelengths of light than Hubble. And so using observations in the near infrared, we're able to see for the first time auroras on Neptune. And so with putting these observations together, it seems that a whole new world lights up. And our solar system, being close to home, is typically going to be where we keep our spacecraft. But as we head farther and farther away, past the farthest point that the farthest away spacecraft has ever reached, our quest for understanding of our universe does not end. Telescopic observations can still tell us a remarkable amount about what lies beyond our solar system. And as we fly away, as we watch the orbits of the planets grow smaller until the sun itself is just a speck, I'm going to ask Marie Antoinette to put up the lines for all 88 IAU-defined constellations. These are stars that humans have looked to for thousands of years. But as we head away from our solar system, away from our Earth, away from everything we've ever known, it seems that even the stars themselves begin to shift. And as we get farther and farther away, no longer even in view of our sun, we'll start to see the structure of the rest of our Milky Way galaxy, which is made of 100 billion stars, and perhaps 100 billion planets, most of them still waiting to be discovered. And all of these stars that we see in the night sky live in just this tiny little section of our entire galaxy. But our galaxy is not alone in the universe. It's part of a small group of galaxies known as the Local Group that contains dozens of small galaxies and just a few large ones like the Milky Way. But over the years, we've mapped many more galaxies farther away from the Local Group, farther away than the Local Group. And when we study these galaxies, we don't just learn about the galaxies themselves. We don't just learn about their structure, about their stage and evolution, about their shape, about how they might be similar to our own or different from our own. Once we map enough galaxies, it tells us something about the universe itself. You see, the light from farther away galaxies takes longer to reach us, and it tells us about the universe when it was younger. And when we fly through very large galaxy surveys, we can see that they've clustered themselves together into some particular shapes. And the way that these galaxy clusters are arranged, and the way that their arrangement has changed over time, because farther away ones is light from longer ago, tells us how the universe has changed over time. And whether our interests lie in cosmology, in galaxies, in planetary science, in solar and stellar physics, there's always something new left to wonder about, left to ask about, left to discover. Each of these points of light is an entire galaxy made of billions of stars. There is so much of the universe left for us to uncover. It's incredibly exciting, frankly. And it helps us remember what these last 4 years were for. Because from our perspective on the Earth, we can gain an incredible perspective of the universe. But as we think about our time at CU, our time on the Earth, we can remember that this is the place where all of our perspectives lie. And this is the one place in the universe where we truly have the power to make a difference. Thank you.
Thank you, Sylvan. Thank you, Marie Antoinette. And I'm realizing that before the ceremony started, I may have misinterpreted a conversation I had with Nick Conant. So Nick, would you like to say a word or two about Marie Antoinette and Sylvan right now? If you have a mic back there, or are they all up here? Okay.
Hi, I'm Nick Conant. I'm the theater manager here at FISC, and I wanted to express my, deep gratitude to the students of FISC who are graduating today and who have graduated yesterday, including Sylvan Arnold, Marie Antoinette Banks, who's graduating in theater and dance, of course, Alanoka, and Grace, and so many more who also are in our audience. Their amazing work here, whether it is in astronomy or not, is actually quite impressive that without even an astronomy degree, Marie Antoinette can do such an amazing flight through the universe, following along with Sylvan, who can present in front of all of you, showing you some of the universe that your own undergraduates will be, or now graduates, will now be exploring in tandem. So I just want to say thank you once again to our students, and I appreciate your journey with us at the FISC Planetarium.
Thank you, Nick, and I just want to impress upon everyone that Marie Antoinette was doing that in real time. Nothing there was pre-programmed. She was flying through the universe. Okay, so thank you again. Next, I'd like to call forward our APS undergraduate speaker, Calvin Adams.
See how you guys like it up here. This is nice. This is a sensitive microphone. Okay. I finished revising this at 1:45 last night, and my heart is racing. So I'm going to try to slow down and take you guys through what I can. This is a very serious day, and I am not a serious person, so I hope there is laughter and love, and there will be a post-ceremony quiz. Okay, where do I begin? The most important part. You guys hear this over and over. If you haven't heard it too many times, I'm so sorry you have to hear it again, but we must give thanks to everyone here. I want to start with the most delightful overlords in the entire CU Boulder community, our faculty, our professors. These people put us here. To the wonderful people at the Fisk Planetarium who makes this possible and makes the most wonderful day ever. Please give a round of applause for them as well. I see the number of loved ones here, and we wouldn't be here without any of you. And so please, as well, give yourselves a round of applause. You guys are why we're here. Okay. Now I will do my best to impart wisdom that I do not have and pretend that I have it all figured out. I have made the greatest friends here, whether that be from crying together through an 8-hour homework session, teaching them how to code, becoming their friend, and then not realizing how awkward it will be to be graduating at the same time. I know like 50% of you. Or absolutely dunking on me in volleyball. You know who you are, and I will get you. These are the kinds of memories and people that shape who we are. If there's one thing that I have learned here as an undergraduate here at APS, it is that E equals MC squared. Remember that, it's very important. You will use it constantly, I promise you. Okay, that's not true. What I truly have learned is that this is the community to be in. These are my people. These are your people. This is our community, and everyone is here to support you, and it's going to take a while, guys, so yeah, and you. Now, what you see above you, I tried my best to gather as many photos of a community as possible. If you do not see yourself, blame your professors. What you see above you is glimpses of who we are, of our friendships, our adventures, our family. We do everything here together. We cry on each other's shoulders when it's 4 a.m., we're in the middle of a desert, and they won't open the telescope because there's too much dust in the air. We watch as our professors clown on us down the ski slopes and proceed to show up to class the next day like they don't know what snow is. We stand there awkwardly, twiddling our thumbs, praying that someone will come to our poster, or avoiding all eye contact like we have the Black Plague. We have the best professors. We do the wildest things, and we have the greatest time doing it. To the graduating class of 2025, let me be real for a second, we suck at graduating, guys. We need to stop graduating. It was COVID first, and now there's no money. If we graduate one more time, the earth will explode. But we are resilient. We may be screwed, but we've done this before, and we can do it again. We found our people, our families have our backs, we've got grit in our teeth, snakes in our boots, and a score to settle. Life isn't going to be easy. We're going to make mistakes, and life will take those opportunities to wipe the floor with us. But we're going to get back up. We always do. And if it means me or any of these people in this room have to drive to your house, shove you out of bed, spoon feed you green Jell-O, and tell you you're pretty, you know damn well that we will be there. I know everyone here suffers from chronic imposter syndrome. My heart is racing. I didn't think I was going to be here, so. But this is your day. You deserve it more than anyone else here. And you should be proud of yourselves, and you will be proud of what you do. Thank you, guys.
Okay, thanks so much, Calvin. Next, we'll proceed to the undergraduate portion of our program. So I'd like to call forward Professor Anne-Marie Madigan, who is the Associate Chair for Undergraduate Education.
Thank you, Professor Brain. I want to say that again, Professor Brain. It's pretty great. Graduating students, you will now receive your diplomas. When you hear your name, please come to the stage to receive your diploma, to shake hands with Professor Brain and pose for a photo. You are also very welcome to say a few words if you would like. Not Calvin, you're done. Parents, friends, we want to invite you to please feel free to move around the room to get the best photo you would like. And I additionally want to say we have one student today graduating with Latin honors. So the College of Arts and Sciences honors program designated Latin honors to students who defend their original piece of research against a terrifying committee. I will announce the Latin honors designation beside that student's name. And finally, a word on etiquette. We're very busy here. The room is almost full. Whooping, loud clapping, anything like that is very much encouraged. Okay. Okay. It's going to seem like we set it up this way. Calvin Adams. Oh yeah, and remember, families can come forward if they like. Calvin, you were allowed to say a couple of things, but okay, you're good. Okay. Sylvan Arnold. Quentin Babcock. Aaron Barrios. Micah Bergeron. David Brennan. Again, you're allowed to speak. Drew Davis.
I want to say thank you to my parents. Thank you. I want to say thank you to my parents who supported me through this. I want to say thank you to my partner. She's wonderful. I want to say thank you to Dustin Tawar for getting me through this degree, baby. Woo, we did it. Woo.
Bibiana Dela Cruz Stewart. Jacob Donaldson.
I do want to say just real quick, thank you to my wonderful parents who have supported me over the last.
Done. If there's a microphone, I'm going to speak. I'm a yapper. What can I say? First off, thank you to my family who have come all the way from Texas and all the way from our northern friend, Canada. Very proud of that. Shout out to my fellow undergrads who made these last 3 years bearable and exciting and so fun to be with. Shout out to Vi, who I met on my first day of undergraduate, and we had like 4 classes together, and we've been here since day 1. So that's been great. Shout out to my professors, amazing people down here. Hey guys. And shout out to Kevy Webby for OBS. It's been great. Yeah. Shout out to my best friends, Glory and Nicole, who have supported me from miles and miles away, all the way in Seattle and Hawaii, respectively. And my Centennial Core family in Centennial, Colorado, who have never failed to make me part of their church family every single day and never stopped sharing their support for me. And thank you to Dave, who I begged to be my mentor that second semester when we were assigned. Dave was my first ever professor that I had at 9 a.m. on Monday morning of those first days of classes. And I think it's very fitting that you're the last person that I see as a student. So thank you for all your work with me these past few years. So thank you.
Sean Gopalakrishnan. Christian Hall. Lucas Henry.
I just want to take a quick moment to firstly express my heartfelt gratitude to the faculty here, pushing me beyond what I thought was possible of my own capabilities. And I want to say a huge thank you to my family, who didn't really have a lot of knowledge about what astrophysics and astronomy might be, but I can safely say I've yapped their ear off, and they can tell you anything that I know now. Yeah, thank you to all the undergraduates for helping support me, and I hope I can support you guys too. Love you guys. Thank you.
Eric Hicks.
I'd like to thank my family for coming out and supporting me today and supporting me all these years. And I'd like to encourage all of you to keep exploring and keep learning and keep looking up, because the ground's not going anywhere and there's incredible things to explore. Thank you.
Sang Lapini. Taline Lian.
Thank you, Mom, Philip, Joe, Julie, Wayne, Noah, Bodie, Ocean. I couldn't have done it without you guys.
John Marr.
Oh, sorry. I'd like to thank my girlfriend and my mom and dad. Thanks, guys.
Sean Manners.
I just want to really quick thank my friends and family and everyone I have worked with on group projects and the faculty and professors. Thank you all.
Maximus Montano.
Thank you to my family and friends for supporting me through this endeavor. Thank you to the staff especially, and especially Professor Kevin. Thank you.
Alan Ochoa.
Hello, y'all. Just wanted to say thank you so much for everyone that helped me get to this point. Special thanks to my family who left their country to come to the United States to give this opportunity to me and my siblings. Thank you for everyone at the planetarium, Tito, Carla, Dr. Keller. Thank you to Kevin France, everyone that has shown me all the amazing things that we can do with this degree, and can't wait to do more. Thank you.
Shelby Up, magna cum laude.
Hello. I want to give a shout out to my family. I'm a first generation student, so this is like kind of a big deal. I would not be able to do it without you guys. I also want to shout out my friends and my boyfriend who are all here. Ryan, Roman, Garrett. And then also shout out to everyone at SBO, Seth. I enjoyed working there for 3 years. It was awesome, highly recommend. And then one last shout out to Dave for being the best department chair and advisor out there. Thank you for supporting me as much as you have the past 2 years, I think. Okay, thank you.
Ryan Roa.
Thank you to everybody here, sitting here tonight. Special thank you, staff, faculty, all my favorite professors got me here today. Dave Brain, you're here at number 1. Thanks for taking me in. My advisor got me through here. Seth, you're the best. Kev Dog, Nick Schneider, thank you very much. Love you all. Thanks for getting me here. Special shout out, thank you, family. Wouldn't be here without you guys. So thank you for getting me here. My heart goes to you. Thank you. Love you guys too. We did it. Thank you, family. Thank you for getting me here.
Emily Elizabeth Rockowitz.
I just wanted to say thank you to my family. Thank you to all my friends, and I especially want to thank my family back home who couldn't make it. This is live streamed, right? Yeah? Well, if this is live stream, I love you, Lolo, and I can't wait to see you. Bye.
Ventura Salazar.
Just want to say thank you to my friends, thank you to my family. Love you, Rennie. Love you so much. Thank you, Seth, so much for all the great teaching lessons, and Kevin and Paul Hain, and Kevin again. Well, different Kevin. Both equally as great Kevins. Thank you, Madigan. Thank you, Professor Ann Sees. And yeah, thank you to my CU family.
We have our youngest graduate yet, Carson Sandiford Hoxie.
Just want to say thanks to my study buddy here. She's got her son toy. Do you want to say any words? There we go. All right. Thank you.
Samuel Schiller.
I just wanted to say thank you to my friends, to my family, to the professors, mentors, and advisors I've had. I couldn't have done it without you. Thank you very much.
Violet Shirley.
Hey guys, I am also a yapper, as per one of my best friends, Shaughnessy, had said previously. I love this department with like my whole body. There is like not a minute that goes by that I'm not thinking about each and every one of you guys and all of the faculty. I've dedicated the last 2.5 years of my life to the Astrophysical and Planetary Sciences department working for Robin Ronen in the office. I spent day after day printing exams, running and getting office keys for faculty members when they forget them. And I just want to say such a big thank you to everybody sitting here. You guys have supported me through and through. Shaughnessy, day one, I love you so much. Talene, thank you for meeting me by chance in the physics help room. To my mom and dad, thank you so much for everything. And also like kind Lucas, everybody who's here for me. Thank you.
Caitlin Staudenmeyer.
I just wanted to shout out my family and my boyfriend. Thank you so much for helping me throughout these 5 years. Thank you to all you, staff, students, and I hope to learn about all these different discoveries and hear about all your discoveries in the future. Thank you.
Dustin Talwar.
Thank you, family. Thank you so much. Thank you to all the undergrads. Thank Thank you so much, Drew Davis. We have gone through so much together. It's been a long road. Shout out to everyone. Go Buffs.
Now, yesterday, I have to admit, I forgot a student, so they didn't get their degree. So I just want to check, have I got everybody? We're good? Does anybody else want a degree? Just on the fly, let's do this. Okay. If not, that was a test question, you all failed. If not, congratulations.
All right, thank you, Professor Madigan. And now we'll proceed to the graduate portion of our program. So I'd like to call forward Professor Zach Berta-Thompson.
Hello. It's my honor to be up here. I am filling in for Professor Julie Comerford, who is out sick, who is the Associate Chair for Graduate Education. But I'm proud to be here because I love our grad students in our department, and I'm so proud of them. And so I just get to be up here and be happy for you. So we have, thanks, Atsuya. So we have students today who will be presenting, we'll be hooding them as celebration of earning their PhDs. So being a graduate student in astrophysics and planetary science, earning your doctorate is, it's a long investment. It's caring deeply about the universe, and it's contributing to humanity's knowledge in a very real way. So everybody that you're going to hear about today has made like real new durable discoveries that affect how we understand the universe around us. And so it's our honor to be welcoming them as colleagues into the kind of senior scientific community. So what's gonna happen is I will read the names of the students and their advisors. We'll have them come up. We'll have the advisor say a few words about the student. We'll have the student say a few words, and then we will put on a funny hood that makes you feel that you are part of this fancy community wearing our very silly clothes. And so it's a very small token of a very big thing that you have done. So our first student today to celebrate is Dr. Tatsuya Akiba, advised by Professor Anne-Marie Madigan. And Tatsuya's thesis is called Eccentric Stellar Dynamics Near Massive Black Holes in the Era of Transients and Gravitational Waves. Yeah!
I wrote a speech, but he's been working for years, so it's not that long in comparison. If you could peer behind the thick veil of gas and dust at the center of most galaxies, you'd find a supermassive black hole, millions to billions of times the mass of the sun, darkly resting in a cluster of stars. Now, when galaxies collide, these central supermassive black holes can find each other and merge. And during the merger, as they swirl around each other, they create ripples in space-time itself that, as you all know, propagate outward at the speed of light. Unlike the ripples you see if you drop a stone into a pond, these gravitational waves are emitted most strongly in a single direction, and in response, the merged supermassive black hole recoils in the opposite. Sometimes they are propelled so fast, at thousands of kilometers per second, that they escape their own galaxy. So, yes, supermassive black holes are quite literally shooting throughout the universe, in case you weren't worried enough already. But these black holes are invisible on their own. You can't see them recoil directly. And what Tatsuya has accomplished in his thesis is to find a way to detect these recoils indirectly by studying the stars that accompany the black hole. He found that the stars that are carried along by a recoiling supermassive black hole form an eccentric disk. That is, all the orbits are aligned and elongated like comet orbits the sun's. This distinctive stellar configuration serves as a clear signpost of a recoiling black hole, And remarkably, this is exactly what we observe in many nearby galaxies, including our closest massive neighbor, Andromeda. Among many important results in Tetsuya's PhD publications, I believe this is the most profound. While evidence of recoiling supermassive black holes has existed for decades, only now are we truly beginning to understand what we're seeing. Now, lest we get too lofty and scientific here, I do want to let you know that the last message I got from Tetsuya on Slack in response to edits I made to his thesis title and abstract was, dope. That is what I have loved about working with you, Tetsuya. You bring an intense passion to your work, you win a frankly embarrassing number of awards, and you join far too many committees. But beyond all that, you bring your full self, your care, kindness, resilience, humor, gratitude, brilliance, vulnerability, and joy. And let me also say a word about your mentorship. Last night, we had a group dinner, crammed as usual into my tiny kitchen. Tetsuya, Connie, Calvin, Sasha, Selah, Gayatri, Adam, Lucy. It's a tiny kitchen. My daughter, Emmy, my friend Lish, and her daughter, Poppy. Your dad, Takashi, who came over from Japan to be here today. Your partner, Meredith, Thundercat. When you left, after cooking for us all, I asked the remaining undergrads what I should say here today. Tetsuya, I wish you could have heard the answers. What we scribbled on the kitchen chalkboard, with the chalk you brought me from Japan, was the sense of community you create, how you listen to your students, make them feel important and valued, and how you make academia better for everyone. That and how much your students love your sweaters. I am so proud of your scientific achievements, Tetsuya. I am equally awed by how you've lifted up those around you. It's been a true honor to be your advisor. Congratulations, Dr. Tetsuya Akiba.
Oh, I hate crying in front of people. My dad is here from Japan. He's awesome. This is really not fair to have her go first. Yeah, my partner Meredith has supported me throughout the journey. Her parents are here today too. I'm thankful for them, and a lot of my friends and family are here as well. And a lot of them are watching probably the live stream, where it's probably 4 in the morning or something back in Japan. So hopefully it's recorded so they can see it later. Yeah, I just want to say a big thank you, and it's been great. It's special. Kelvin is one of my undergrad mentees. He's graduating with his bachelor's with me today, and 2 of my best friends are graduating with me as well. Yeah, I just wanted to say thank you so much, and I probably missed a lot of important people, but I'll keep it short, and I'll say my thank you later. So, thanks.
Our next PhD student is Imogen Cresswell, advised by, Dr. Imogen Cresswell, advised by Professor Ben Brown.
Just gotta drag it out for everybody. Hello.
Amazing. Friends, families, colleagues, it is my great pleasure to present you Dr. Imogen Cresswell. Amy joined us here in the Department of Astrophysical and Planetary Sciences in fall of 2019, having already earned a master's in science, which she undertook in the United Kingdom under Professor Tammy Rogers in Newcastle University. Tammy was a close mentor to me when I was a young, brash graduate student and gave me some of the best advice I've gotten in my career. And so when Tammy told me that one of the best students and best people she had ever worked with was coming to work with me, I had some small idea of what to expect, but it was underselling things, if anything. Amy showed up in fall of 2019 and then had a perfectly normal graduate career just like everyone else. Amy was in the first class of students that crashed out during COVID, had to deal with long distance learning, Zoom lectures for 18 months. We were locked out of our labs for the greater part of 18 months. Through all of that, Amy consistently persevered. She has continuously shown exceptional drive, independence, and fortitude through everything. As you can see, as she stands here next to me on crutches. Amy did exceptional work working with me and a team of other people, probing the fundamental fluid dynamics of stellar interiors. She studied the properties and transport processes that occur in stars like our sun, in white dwarf stars, and in red giant stars. A portion of her work addressed magnetoconvection, what happens to plasma motions in very strong magnetic fields, like in our sun's sunspots at its surface. The work she did there is groundbreaking and in a field where very few people have dared to tread. She also did exceptional work on thermohaline mixing. What happens when chemical composition and temperature together work to create transport inside stars, like white dwarfs and red giants, a phenomena that also happens in the Earth's oceans. Amy did this creating her own collaborations and networks nationally and internationally, reaching as far away as the United Kingdom, back at University of Edinburgh, and all over our nation. She did this also with an advisor who was not there to help her for most of it, because I spent a great portion of Amy's graduate career on the central coast of California, where my family had to move during the pandemic. And yet Amy consistently showed up over and over again, having created amazing works on her own, asking for my advice on the next steps we should take forward. Amy has acted as a colleague from the day that I have met her, and I am glad that you get to see her as a colleague today. Some of this is best exemplified by an exchange about 2 weeks ago when we were submitting Amy's thesis right before the deadline when it is due. And I'm rapidly sending her Slack messages as she's trying to get my help getting other committee member to sign off. I'm like, by the way, so sorry for dropping the ball and getting you edits. Totally my bad. Whatever you have, let's get it in and done. And she responds nonchalantly, well, I happen to have broken my leg right after my defense and I had surgery, so I'm a little slow on my edits as well. As she was submitting her final thesis to the campus was the first I ever knew that she had broken her leg, because Amy was like, broken leg, surgery, I've got this. Amy is an exceptionally intelligent, independent, and strong person. I have been so proud to get to work with her as a colleague, and I am so excited to support her in the things she does moving forward in this world. I'm going to stop talking now because I could go on forever because I am a professor. I'm going to hood Amy and then give her a chance to talk to you so we can get her off of her crutches.
Hello. shout out to Kirk and the Rocket A Basin for sponsoring my footwear this evening. I want to say thank you to Ben. It's been an incredible journey, and he supported me throughout, sending me wherever I desired to go in support of my academic endeavors, I guess. So thank you for that. Thank you to my amazing boyfriend for supporting me through both my thesis and my broken leg. I don't know which he hated more. I'm lucky to graduate today with two of my best friends, Tatsuya and Joshua, although Tatsuya's cancelled for making me cry before I came up here. And then my other best friend, Amy, in the stands waiting to graduate in the fall. So it's really amazing to be able to graduate with my 3 best friends from my cohort. All my other friends in the audience, I'm so grateful. Thank you for your support as well. Meredith, you're amazing, and you're part of APS anyway, so thank you. And then thank you to all the professors and everyone who supported me through this. It's been a long 6 years, and here we are. Thank you. Thank you to my parents. I can't believe I forgot. I was like, I had it all in my head. I was going to thank my parents because they, my gosh, they have supported me through absolutely everything, all the way across here. They said to me, "Why do you want to go to America all that way?" And then they came to Colorado and was like, "Yes, I see why." But the support from all that miles away, like I wouldn't have been able to do it without them. So. Thank you, and I'm sorry for forgetting.
Our final PhD student today is Dr. Joshua Hibbard, advised by Dr. Jack Burns and Dr. David Rapetti. And I believe neither of them are here. Oh, no. Oh,
yes, I am. I'm not either David Rapetti or your advisor, Jack Burns, Professor Jack Burns, but I am Andrew Hamilton, and I've known you ever since you arrived at Boulder, and you're a wonderful person, and it's an honor to have the opportunity to say a few words about you. Right now, Jack Burns, Professor Jack Burns, is doing something really important in Holland, so he can't be with us. But he's sent me a little speech, which I will read out. It says, "Joshua Hibbard has become a remarkable scientist. As faculty mentors, we watch with fascination and encouragement as our new graduate students take their first tentative steps towards becoming research scientists in their first few years in graduate school. Inevitably, they blossom into full-blown colleagues by the time they defend their dissertation. Joshua did this and much more. He is the first author on 6 papers in the Astrophysical journal and co-author on 3 more. His work is breaking through barriers to investigate the unexplored dark ages of the early universe, a time before the stars and galaxies formed and beyond what even the James Webb Space Telescope can observe. Using low-frequency radio telescopes on the moon, we can uniquely probe potential new physics in this new window on the universe. For his last paper in his dissertation, Joshua led the effort to analyze the data from the first NASA radio telescope that landed on the moon in February 2024. That's just a year ago. This was a Herculean effort as it required an entirely new approach to data calibration and data analysis, which Joshua has elegantly mastered. Joshua's start in my research group, that is in Jack Burns' research group 6 years ago, was not smooth. He overslept and missed his first meeting with our research team. Josh more than compensated that faux pas by overperforming on one research project after another. I've had the privilege of mentoring over 45 PhD students and postdoctoral fellows, over the last 45 years. Josh has been a pure joy to guide on his journey through graduate school. For many conversations we've had about matrix algebra, radio telescopes, cosmology, and politics, they'll stick with me for many years to come. I wish Joshua much success as he continues his journey as a postdoctoral fellow. He will be deeply missed. I'm sorry to say I brought my own speech. So you're going to have to listen to some more of this. And I think, Ray, we have a couple of cartoons to add to the background here. So this is from the far side, Gary Larson. What Professor Burns failed to mention or neglected to mention is the spacecraft that landed a year ago on the moon did a faceplant. I've written down here, would you like to adjust to illustrate the position? But you don't have to do that if you don't want to. That meant its antenna and solar panels were pointed in the wrong direction, which wasn't a very helpful thing to happen to the data that was supposed to go in your thesis anyway. But you, Josh, proceeded and analyzed it anyway, because you were persistent. Why have I put up these little cartoons here, apart from the fact that they're relevant moon far side cartoons? They're an illustration of the fact that things go wrong. They inevitably go wrong. Doesn't it happen? And what you do as scientists when things go wrong, and they always go wrong, is you get up and you persevere. In fact, if you've been as wrong as often as I have, because I'm getting old, then you learn that failure is one of the most cathartic things, because you get up and you fight harder. If you have it easy, you relax, and then you do nothing. So it's good to fight. I'm not done yet. Josh will be going to, I'm going to tell you what's going to happen to. He'll be going to UC Berkeley in the fall to work with a team led by Professor Stuart Bale. He is the leader of the LUC team. That's one of those awful acronyms, meaning Lunar Surface Electromagnetic Experiment. And it's a mission to land on the lunar far side. Now you get it. Josh, you can probably, I'll let you explain more about the details of that. After Josh successfully defended his PhD thesis a month ago, his advisor, Jack Burns, took us all out to dinner at a restaurant on Pearl Street. Professor Stuart Bale, who is employing you, was part of the party as a member of the thesis committee. And I asked Stuart, have you hired him? And he said, yes. And I asked him a second question. I said, was there anybody else you considered even hiring? And he said, no, Joshua is the only one. I want to say a few personal things about Josh. Although he has his feet firmly planted on the moon, his head is where it should be, up in the clouds. He is fascinated, as I am, and as many of you are, by the deep secrets of the universe, such as what happened at the Big Bang, what happens inside black holes, yes, and what is still the unknown theory of quantum gravity. There's a joke amongst the graduate students, and Tatsuya, it's you, I think, who started this joke, that when the department has a picnic, Josh and Andrew get together, that's me, Andrew Hamilton, and we'll sooner or later start talking deep science. And of course, what happens is the rest of the graduate students slowly melt away, and the faculty become more and more distanced so that they get out of earshot of what we're talking about, leaving the two of us in our own scientific heaven. So thank you, Josh. I will miss you. You're going to Berkeley. I have people in Berkeley, so I will be coming by. Josh, congratulations, Dr. Joshua Hibbard.
this one, or? This is fine. Yeah, well, I just wanted to thank Andrew again for stepping up for me and doing this whole ceremony and your speech. It's really great, and I have to say I'm also going to very much miss our conversations. And I just wanted to say that I owe so much to so many people for making it this point in my academic career, and many of them are all here in this room, the prettier ones, of course. And but in particular, my parents and my family and grandparents who encouraged me as a child to pursue science since I was young. And I still remember first getting books with pictures from the Hubble Space Telescope, and they affect me as much today as they did then. And then discovering physics later in high school with Mr. Boulder, falling in love with cosmology in college with my advisor there, and then finally finding my way to lunar radio telescopes with my advisor, Jack Burns. And I just wanted to thank him, and he has worked tirelessly to further my career and encouraged my ideas and pushed me to attain the seemingly unattainable. And as people who work at 21 centimeter land know, it is a far-flung dream, but one that we hope is slowly becoming reality. And I've also learned much from Jack, who is extremely well connected about grant writing, NASA, and how to extract money from bureaucrats. I've thoroughly enjoyed our conversations over these 6 years, and I look forward to them. And I just wanted to say, too, that I think two principal forces have guided my life to this point, two motivations that sort of stand titanic above all others, seeking friendship and seeking knowledge. And I think the universe we find in the company of our fellow creatures and the universe we find in seeking out the mysteries of the stars. And in case you forget, though we are on a planet spinning amidst the stars, we were born from stardust, and so the stars are in us. And so I just want to say it's been my greatest pleasure to have found both of these, both friendship and knowledge, throughout my time, especially here in Boulder with my colleagues. And especially my friends that have supported me through it, and my parents, and my two really good friends that are also graduating, and are one as well that Amy mentioned is graduating in the fall. So thank you all very much.
Okay, thank you very much. That concludes the graduate portion of our program. So congratulations, we're halfway through the ceremony. I'm just kidding, we're very close to being done. So thank you, Professor Berta Thompson, and to the graduate students and their advisors. I just have a few words of closing here. Most of this is logistical, and so I have to try and remember all of the things. First, to the audience, thanks a lot for indulging us in this ceremony. We're really proud of the ceremony here in APS, of being able to have it in the planetarium in this just wonderful, peaceful place. It's disappointing that we have to break the ceremony into 2 separate days rather than having everyone be together at the same time, but to us it's worth it to be here. Also, thank you for indulging us in terms of time. We feel that it's special to give every student a chance to speak, to have graduate students and undergraduate students mixed together to really honor all of their achievements in the way that they deserve to be honored. And that takes a little bit of extra time, so thank you. SBO, both? No, okay. The Summers Bausch Observatory is right up the hill. Your graduate can help you find that if you would like. It is open now, immediately following the ceremony for an hour or so. If you'd like to go up and look with your graduate, Emmy, you might want to skip it because accessibility is a bit of an issue with SBO. Right now, there's some construction out front, I'm really sorry, and so you have to go around the Speech and Hearing Sciences building and then up a dirt road with potholes, and I think they're bears and things like that too, but you're totally encouraged to go. Sorry, Seth. The director of the observatory is sitting right there like, why are you telling them they're bears? Okay. In terms of recessional, that's what we're going to do in just a moment. There are a few comments to make. The faculty will leave first, followed by the graduates. Graduates, on your way out, there's a mug that you can grab from a table or will be handed to you, but don't stop walking. Keep walking to the doors of the planetarium. And then when you go out the doors of the planetarium, keep walking, because there are people behind you that would also like to get out of the doors. And walk far enough where you can assemble for a picture. We'll wait 2 or 3 minutes to make sure everyone gets out, because after the graduates will be everyone else here in the theater with us. As you go out of the planetarium, don't dawdle too much, because we're going to start taking pictures. And when you go out the doors of the planetarium, you will also keep walking, recognizing that there are other families behind you that would like to get out of the planetarium and take pictures of their graduates. And so maybe 3 or 4 minutes after we're all out there, we'll all line up with the faculty and the graduates together and take some pictures. And then the faculty will very wisely step aside, and we'll do a picture of just the graduates and then a picture of the graduates throwing their caps in the air. We'll only do that one time. Okay, great. And so with that, I think those are all of the logistical things. So thank you all for being here, and please let's thank our graduates just one more time.